Okay, day 2 notes. Today we are going to talk about more exponential functions. The whole goal of these notes are to be able to graph. You have to be able to graph exponential functions. We're going to talk about the basics, and then we're going to do a little bit of a review with some of the transformations when you take a graph and you shift it or you reflect it. Before we do any graphing, though, we have to remember how to evaluate something, so that's what we're going to do in the first example. One thing that I want to remind you of is when we say exponential function, we mean some number to a power. And we are only going to be looking at positive numbers to a power. Part A, we're just evaluating. So it says evaluate f of x equals 5 to the x for the following 3 values. Okay, x equals 3. That means I'm doing 5 to the third. Maybe, hopefully we can do that in our head. If not, use a calculator. What's 5 to the third? 125. That's it, done. Next one, 5 to the negative second. Okay, before we do that one, what is 5 to the second power? 25. What does the negative power do? What? Flips it. It does not make it negative 25. Doesn't make it negative 25. Instead, it flips it, becomes 1 over 25. Last one, 5 to the 0. What is anything to the 0 power? 1. We are going to be using these ideas to graph. Any questions before we move on and look at some graphs? Okay, so here we go. You see some examples. The equations are to the right. We have 2 to the x, 4 to the x, and 10 to the x. All 3 of them are being graphed. What do you notice?
They pass through the same y-intercept.
Yeah, so that's one thing that hopefully we notice. All 3 of them have the same y-intercept, and it's 0, 1. What else do we notice? Maybe just in general. Elliot?
They all go through the x that, like y equals 2x goes through 2 on the x-axis.
Yeah, exactly. Very good. Y equals 2x gives us the point 1, comma 2. 4x gives us the point 1, comma 4. 10x gives us the point 1, comma 10. And that should make sense. If we plug in 1, we get 2. If we plug in 1, we get 4. If we plug in 1, we get 10. Good so far? What's the last thing that we notice? Again, the last one is just a general observation. Related.
Are they all going to positive infinity?
Okay, they're all going to positive infinity. What is the difference as we go from 2x to 10x? In terms of like the slope. It's steeper. You see that? Higher number is going to be a steeper graph. Okay, those are the things I need us to know. The biggest ones are the 2 that Adam and Elliot pointed out. Every graph is going to go through 0, 1, and then they're going to go through the point 1, comma the base. If you can remember those 2 things, you should be able to graph anything. Sound good? Okay, let's look at some examples. This summary, you don't need to know. You can just ignore it. So go to the next page and look at some examples. Okay, so here's the way that you're going to approach this. First of all, reading the directions, it says graph each exponential function, include 2 exact points and the horizontal asymptote. Okay, y equals 3 to the x. Like Adam pointed out, every single one of these graphs is going to go through the point 0, 1. And then, like Elliot pointed out, it's going to be 1, comma the base. Those are our 2 points. So let's graph those. 0, 1, 1, 3. Okay. Then like Maria pointed out to us, every graph goes to infinity. So if we connect those 2 points, they're going to go up to infinity. And then it's going to come back down and hug the y-axis but not cross it. The reason is that there's a horizontal asymptote here. Questions before we look at the next one? Okay. The next one in B is going to be a little bit different. So I need you to listen because this is different than how you've graphed in the past. What we're going to do in something like B is we are going to start out by considering the general function. Just the basic function of 3 to the x. So we're going to ignore the -1 and we're going to ignore the 2. We're just going to consider 3 to the x. Again, from on the left, we know that this graph will go through 0, 1, and 1, 3. Now what we're going to do is we're going to graph what we're asked to do by considering the -1 and the +2. What is that -1 going to do to the graph? It what? Say it one more time. Flips it. Not quite, but thank you.
Is it reflected, the graph?
That's what Maria meant by flipped. So not quite. Okay. Anything that's attached to the x affects x. This is one that's going to move us left or right. -1, what direction is it going to move us? Huh? Right. With x, it's always the opposite of what we think it's going to be. So that -1 is going to move us right 1. Okay, the +2, since it's not attached to the x, is going to affect y. What is that going to do? Up 2. Okay, so what's going to happen then is these 2 points are going to move right 1 and up 2. I'm going to do the right first, and then I'll do the up. So I have to picture, if I have a point at 0, 1, and I move it right 1, the x-coordinate is now 1. If I have a point at 1, 3, and I move it right 1, the x-coordinate is now 2. And then I'm going to change to the up. If I have a value of 1 and I move it up 2 units, it's now going to be at 3. And then if I have a y-coordinate of 3 and I move it up 2, it's going to be at 5. Okay, what I would like you all to do is plot those 2 points, please. Plot those 2 points and sketch the general shape of the graph. Here are my 2 points. Before I connect them, I need to consider the asymptote. Is the asymptote in the same place as it was in A? Do we have anything in our equation that would move the asymptote? Yeah, that +2 is going to move our asymptote up 2. So before you connect the dots, what you're going to want to do is move the asymptote up 2 units. And then you should be able to finish the graph. Goes up to infinity, comes down, hugs the asymptote, but doesn't cross it. So that is always going to be the idea, is look at the original graph, then make the changes. Now, if you're not sure about your changes, plug in the values. If we plug in the value of 1, we get 3 to the 0, which is 1, plus 2 is 3. If we plug in 2, 3 to the first is 3, plus 2 is 5. So that's always a way to check. Questions before we do 2 more?
So the 2 on the outside affects the y.
Yep.
And the asymptote.
Correct, because the asymptote has to do with y. Okay, so let's do 2 more, and then that is the notes for today. Okay, in something like C, the original function is just plain old 2 to the x. The original function is plain old 2 to the x. We're not going to consider that negative yet. every single graph is going to go through 0, 1. And then we know if we plug in 1, we're going to get the base of 2. Okay, we only have one change, and it's that negative in the exponent. If it's in the exponent, it affects x. What do we think that negative is going to do? Yeah, it's going to flip the x's. So each x will now be negative. So the first point stays the same, but the second point will become negative 1, 2. If we haven't done anything to y, the asymptote is not going to change. So we haven't changed y at all, which means our asymptote is still at y equals 0. So then I have 0, 1, negative 1, 2. It's going to be the same general shape. It's going to go up to infinity this time on the left side, and then it's going to hug the asymptote on the right. I'm going to be picky about you having arrows on the end, and I'm going to be picky about you approaching the asymptote but not crossing it. Okay, what I would like you to do now is take 3 minutes and do D. Take 3 minutes and do example D, please. This is the graph that I got. So ultimately, my 2 points ended up at negative 3, 0 and negative 2, 1. I showed a little bit of extra work at the bottom. If you're not sure if your points are right, plug in negative 3, and you'll see that I got 0. And then if you plug in negative 2, you'll see that I got 1. How do we feel about this? Basically, it's can you remember the right 2 points, and can you move them the correct direction? That's it.